Hello and welcome to Math 533, Topics in Euclidean Geometry, in the fall semester of 2025. This semester we're offering this class as an online class. It's primarily going to be an asynchronous class, though there is one component on Monday afternoons. We meet from 4:30 to 5:30 on Zoom. Attendance is strongly recommended, though it's not absolutely required. In this video, I'm going to introduce the class and basically give an overview of the syllabus. All of the details are to be found in the course syllabus that's posted on Blackboard. Let me start by introducing myself. My name is Sam Lisi. You can call me Dr. Lisi. My email address is stlisi@olemiss.edu, and this is the best way to get a hold of me. If you have any questions or anything you want to discuss having to do with the course material, emailing me is a great way of getting in touch. My office is Hume 318. It'll look familiar if you come visit me, since this is where I'm recording right now. And I do have office hours. I'm going to have office hours both in person in my office in this Hume 318, and I also have some office hours that are going to be on Zoom. Also, I am happy to schedule an appointment outside of office hours. So send me an email if you want to schedule a meeting. We can meet either in person here or we can meet on Zoom. Also, I'm aware of the fact that a number of you have commitments during the day, either from a job or from a student teaching placement. So I'm happy to schedule a meeting either in the evenings or on the weekend. Finally, we do have, as I mentioned previously, we have this 1 hour a week Zoom meeting for discussion. That's a great opportunity to bring up any questions, especially those that would be of interest to more than just yourself. So for instance, questions about the homework or about a topic we're discussing in class. And we also have a course discussion forum. I will be checking that regularly. That's a great place to ask a question also that would be of interest to more than just yourself. This class has a prerequisite. The prerequisite is Math 305, which is the Foundations of Mathematics class. The key topics from that class that we're going to be building on in this geometry class, we're going to use mathematical logic. So things like how to negate a statement is going to be quite important. We're going to talk a little bit about sets and, to a lesser degree, functions and equivalence relations. And the most important part is we're going to talk a lot about mathematical proof. So we will have direct proofs, proof by contraposition, proof by contradiction, proofs of if and only if statements. So there are going to be a number of important kinds of proofs in our class that we're going to need to use. So ideally, brush up a little bit on this. It's okay if it's a little bit rusty. We will do some review when it's appropriate of these various concepts, and we will be spending a lot of time on mathematical proof this semester. So what is this class about? This class is about Euclidean geometry, just like it says in the course title. So really this question is, what is Euclidean geometry? To a lesser extent, the question is also, why do we study it? So Euclidean geometry is the name that we give to the field of mathematics most closely related to the work of an ancient Greek mathematician named Euclid of Alexandria. Euclid of Alexandria published a treatise somewhere around 300 BC, and that treatise is called The Elements. The Elements consists of 13 books. The first 6 of those books talk about geometry in the plane. So this is the kind of geometry that you maybe remember from high school, where you do geometry in this two-dimensional plane. So it's the geometry maybe of the blackboard or of a sheet of paper. Euclid did more than just geometry in the Elements. He also discusses some amount of what we now call elementary number theory. Famously, Euclid gives a proof that there are infinitely many prime numbers He also introduces something we now call the Euclidean algorithm to find the greatest common divisor of two integers. We're going to leave that number theory to the side. That's not the topic of our current class. Euclid also talks a bit at the end of the Elements about solid geometry. That's another topic we're going to leave to the side for this semester, and we're going to focus on the content of those first 6 books and on a modern reinterpretation of them and how they fit into a more modern setting. So plane geometry is what we're going to focus on. Now, a very natural question is, why do we study Euclidean geometry? It's more than 2 millennia old, and right, you might argue that working in 2 dimensions is very limiting. Now, there are many answers to that question. Some are more satisfying to some people than others. And I will just give a couple and throw the floor open for you all to discuss it in your discussion post this week. So one classic reason is that it has historically been an important part of European traditional classical education. So an educated person in the Western tradition, so in Europe or in the United States, would have probably studied Euclid in maybe in Greek or in Latin or in more recent translations into English or French or whatever. And this would have persisted until, I guess, the beginning of the 20th century. Famously, an example of this is Abraham Lincoln. Abraham Lincoln, as a young lawyer, and then early in his time as a senator, he studied Euclid's geometry books, so those first 6 books of Euclid, in order to improve his skills as a lawyer, to improve his argumentation skills, his ability to construct an argument, and to convince people of what he was saying. From my perspective as a mathematician, there's an important influence of Euclid to this day on the way we do mathematics. So the perspective that Euclid takes of stating theorems, giving proofs of them, talking about axioms, the way he makes definitions, all of that has lasting influence on the way we do mathematics today. So I find it very interesting to see Euclid's perspective and how this has been refined and built upon over the centuries. Of course, for those of you who are interested in secondary education as a career, Euclidean geometry is and remains an important part of what we expect all high school students to study. So it is an important part of both the middle school and high school curriculum in any of the education standards that we have, for instance, according to the Mississippi College and Career Readiness standards. In this class, we will primarily focus on Euclidean geometry, like I said, and we will focus very heavily on writing mathematical proofs. Now, I should say there are other geometries out there, the most famous one of which, at least in our day-to-day lives, is the spherical geometry. Right? This is not something that lives on a blackboard. This is a sphere, and this is a representation of a very important sphere in our lives. Right? So if you're interested in any question of navigation, for instance, of ships or of airplanes, or if you're interested in satellites, you are not interested in Euclidean geometry. You are instead interested in spherical geometry. At the very beginning of this class, we will talk about some of the non-Euclidean geometries that exist. Very quickly then to move on and only focus on Euclidean geometry. This class is going to be organized into 3 modules. Each module is going to take roughly a third of the semester. So about 4 to 5 weeks for each one of these. Our first module is going to be on axiomatic systems. We'll of course explain what that means. I don't expect you to know what those words mean directly, but this is the perspective that Euclid takes in the elements. He builds up an axiomatic system and then proves things in that axiomatic system. Then the second topic we're going to talk about, and I should say this is, right, that's very much following Euclid. Then we're going to look at transformations. Transformations, we're going to think of things like translations of the plane, rotations, reflections, things like that. This perspective on geometry places transformations at the heart of the discussion. And this is an idea quite often attributed to the mathematician Felix Klein from the 1870s. And this perspective is very important for two reasons. One of them is that is a perspective that's emphasized both in the Common Core standards and in the Mississippi College and Career Readiness standards. So that's, right, so for those of you interested in secondary education, that's essential. The other thing that's important about transformations is this perspective from Klein proved to be deeply influential on later developments of mathematics. And I would say that a huge amount of 20th century mathematics grew out of this perspective of Klein and continues to be felt to this day. In some sense, one might be able to argue that this perspective also is one of the ingredients, I'm not saying the only ingredient, but one of the ingredients in Einstein's development of general relativity once he'd understood special relativity first. Okay, so that's our second module. And then our third module is going to be on similarity, right? So like things like similar triangles. This is obviously a very important part of Euclidean geometry. If you think back to various things that you might have done with it in high school, it allows us to solve a large number of problems. And in this module, we're also going to see the proof of what might be the world's most famous theorem, the famous Pythagorean theorem. Right, if I have a right triangle here, let's say the hypotenuse has length c, and the two legs of my right triangle have lengths a and b. As you all know, I get a squared plus b squared equals c squared. So this Pythagorean theorem, I would say it's the one you're most likely to discover that somebody can state for you. It is a very important theorem, and we'll see it here in this context of similarity. Okay, let's talk about assessment. There are going to be 4 or 5 different kinds of assessed work in this class. 4 if you're an undergraduate, 5 if you're a graduate student. The first one is forum participation. So I expect you to participate in our class discussion forum basically weekly. We also will have basically weekly a homework assignment due. So I have two different categories of homework. One of them is the so-called regular homework, where you submit the homework and you get feedback and a grade, where you get partial credit if you partially solve the problem. We will also have some mastery-based homework. And what that means is I will, on occasion, so this will be less frequent than the regular homework, but I will give you a problem. Typically, it'll be a proof to write. And I will ask you to resubmit your work if it doesn't meet the standard that I require of it. Right? So there's your homework, the mastery homework, you will be able to resubmit it until the end of the semester. The other kind of assessment we have here are going to be some oral exams. We're going to have one oral exam at the end of each of our 3 modules, so there are going to be 3 oral exams. The dates, we're going to have to schedule them, of course, but the weeks in which they will take place are specified on the syllabus. The last one is going to be during the final exam week, as set by the registrar. And then finally, for those of you enrolled for graduate credit, you will have your graduate end-of-term project that you need to submit. Now, oral exams are a little bit unusual, perhaps, at least here at the University of Mississippi. So let me say a few more words about that. Before the exam, I will give you a study guide. And the study guide will list the various categories of questions I might ask you. Categories you're likely to see are things like definitions, theorem statements, theorem proofs, and maybe some problems. Not every oral exam will have all 4 of these, but many of them will have some number of those. And I will tell you how many questions I'm going to ask you from each category and the grading rubric. So everything should be clear to you before you enter the oral exam. And then I will ask you the questions during the oral exam and grade you according to the rubric. So we will discuss this in greater detail before the first oral exam, of course, and I will make sure that it's not a stressful experience.